Lesson does hinge on your understanding of factoring, okay? Not so much in the lesson, but there are problems in the homework that require you to know some of the factoring skills we talked about in 9.1. So if you do get stuck on what factoring skills to use, I recommend referencing your 9.1 notes to help you out during the homework for today's lesson. All right, so today we're going to be doing 9.2, which is going to be simplifying rational expressions. So a rational expression is a fraction whose numerator and denominator are non-zero polynomial expressions. A rational function is a function defined by a rational expression where the polynomial in the denominator is not equal to 0. So we all know that we can't have zeros in the denominator in math. This is pretty true throughout almost every math course you'll ever take. So yeah, always be on the lookout for that. And only common factors can be divided out. You cannot divide out common terms, so it has to be an entire factor. And we'll talk about how you can identify those things. So let's go ahead and take a look at this first example right here. So first thing you want to do when you see a rational function is you want to see if you can factor the numerator and the denominator. You're going to factor them separately, okay? So I see that my numerator is a trinomial, so I'm going to see if I can factor it into two binomials. So we're looking for factors of negative 12 that add up to negative 4. Any ideas?
Negative 6 and 2.
Very good. Negative 6 and positive 2. So now we're going to look at our denominator. So we call this the difference of perfect
Squares.
Good. So difference of perfect squares, we know it's a plus and a minus, and it's the square root of each of those terms. So it's going to be x and 2, square root of 4. Now before you go about canceling anything that can be canceled out, that is common in the numerator and the denominator, you want to first set each piece of the denominator equal to 0 to find what we call the restrictions, okay? So you take each product in the denominator and set it equal to 0. And then you're just going to solve for x in both cases.
Haven't we done something similar to this before?
Yes, we have. You're going to see a lot of commonalities in this topic. So the restrictions in this problem are negative 2 and positive 2. You need to address any variables which will make that denominator 0. So I see that if I plug in a negative 2 here, or I plug in a positive 2 here, either one of those is going to give me 0 in the entire denominator, because this is going to be 0 times whatever this is, and then 0 times whatever this is. They're both going to give me 0 in either scenario. So I need to make sure I identify those, because it can't exist if the denominator is 0. So now, once we've done that part, we're going to look at the actual expression itself right here, and we're going to see if we can cancel anything out. So we have anything common in the numerator and denominator here?
X plus 2.
Good. So we can actually cancel out those x plus 2's, and we're left with x minus 6 over x minus 2 as my final answer. And you don't have to put parentheses anymore, but I like to put them in. It's up to you. But yeah, that's our final answer. So does everybody see why it's so important we find restrictions before we start canceling stuff out? If we tried to find restrictions right now, would we have found all the restrictions?
No.
No, we would be missing one of them. Okay, so it's always important you find restrictions before canceling. Now, since you are going to be in the ACT tomorrow, so many of you, I want to mention, you may also see this restriction written as x cannot be plus or minus 2. Okay, that's another way they could have written that scenario. I'm not expecting you to have to write it that way. I just want to show you all the possible representations. So you pick and choose what you want to do. So now we're going to look at monomials. Monomial is defined by a single term. The easiest way to identify a monomial is that there is no plus or minus sign in there. Okay? A minus sign doesn't mean like a negative. I mean like between two operations, or an operation. So the first thing you do is you deal with the numerical portion. So how many times does negative 6 go into 24?
3.
Negative
4.
Negative 4. So I just I do the numerical part first, okay? Now I'm going to go about doing the variable part. So here's how you do the variables. You look for a common variable. We have the x's right here, okay? You look at the exponent. When you divide exponents, you subtract. When you add exponents, you multiply. So, you take the larger of the two exponents, 5. What is 5 minus 2? Regular 3. So what you're going to do is, whatever one has the bigger exponent to begin with is the spot that keeps the variable. Okay, see how the denominator had the bigger exponent? That keeps the variable. Okay. What is 4 minus 3?
1.
So it's going to be y. Is the y going to stay on the numerator or denominator? Numerator, because it has the bigger exponent to begin with. Now, what I forgot to do is get the restrictions. So in order to get the restrictions, I actually have to go back to the original monomial here. So what can't x and y be in this one? What would give me a problem if either one of them were what? 0. If x or y were 0, wouldn't that make my whole denominator 0? Because when you multiply by 0, what do you get?
0.
0. So that's my final answer, and yeah, that's how you do it. All right, let's try another one. So this is the product of two monomial rational expressions. A few different ways you can deal with this. Whenever you want to multiply fractions together, you can simply multiply straight across, the numerator times numerator, denominator times denominator. And if you're going to do that, you're going to start getting some big numbers. You're going to get 60 over 36 with a bunch of variables. So I want to show you a little trick called cross-canceling. Now, if you don't feel comfortable with cross-canceling, feel free to do it the long way, but I do want to show you this alternative method, especially since SAT and ACT are timed tests. I want you to be able to make the most of your time. So here's how you cross-cancel. You look at the diagonals. Okay, I'm going to look at the 2 and the 10 diagonal. Everybody with me? Now, what is the largest number that the 2 and the 10 are both divisible by?
5.
2.
2. What is 2 divided by 2?
1.
1.
What is 10 divided by 2?
5.
Okay, that's cross-canceling. Now we're going to do the same thing for the other diagonals. What is the 6 and the 18 both largest divisible? Yes, you got the idea. And then 18 is going to become 3. So when you decide to cross-cancel, make sure you divide both the diagonals by the same number. Okay. Now the benefit of this is now the numbers are much smaller, easier to work with when we go to do the multiplication. So now I'm going to multiply across to make this into one big fraction. So what is 1 times 5?
5.
What is x squared times x cubed?
X.
Fifth. Remember, you add exponents when you multiply. What is y cubed times y squared?
Y.
Y to 5.
Good. 1 times 3?
3.
It's just x because you're not multiplying x by any other x. And then y to the
6.
6th. Now we've dealt with the numerical portion. This can't be simplified anymore, but we can simplify the variables. But before we do, let's find the restrictions. What can't x and y be here?
0.
Very good. Okay. Now we're going to go ahead and divide with our variables. So, what is going to happen here is this is an implied 1, right? So what's 5 minus 1?
4.
Good, it's going to stay on top. And what is 6 minus 5?
1.
It's going to stay on
The bottom.
the bottom. So everybody understand the top-bottom situation?
Yes.
Okay. That's really the easiest way I can explain it to you. Okay. All right. Letter C. We're going to use that cross-canceling thing again. So if I look at these diagonals first, what can I divide 15 and 5 by?
5.
Good. This is going to become 1, and this is going to become
3.
good. What about the other diagonals?
4.
4.
It's also going to become 1 and 3. And you can actually do this with variables as well. I just find that it's easier to do it later, but you really can do it that way too. So on the top, I'm going to get 1, right? I don't need to write that though. I'm going to get a to the 5th, b to the
12.
no 8th. Remember, you add, not multiply.
Oh, yeah.
That's okay.
B to the 8.
All right, is everybody with me on how I got to this point? What would be my restrictions?
U.
0 on both. So does anyone have any questions about what I have in the orange right now? You see how I got there? Alright, now we're going to go ahead and cancel. What is a to the 5th divided by a to the 5th?
1.
1. Those completely go away because they have the same exponent, same power, everything. And then the b's. What's going to happen with the b's? B to the,
Second.
it's going to be in the,
Bottom.
yes. And then we don't have anything on top, so you just put a 1 when you don't have anything left on the top. Because you don't see fractions that just have denominators. You see numerators, which is just numbers, but that is our answer. Can't do anything else with that. Okay. So this is easier than it looks. Whenever you see that -1 exponent, all it means is whatever that expression is, it goes into the denominator. Okay, that's literally all it is. Okay? Alright, moving on. How many times does 4 go into 8?
2.
Good. A divided by, well, this is going to become a to the, and then this is going to become just a b in the denominator, right? And what are my restrictions?
0.
0 and 0.
On both.
That did not work out right. There we go. Okay. So does anybody have any questions about these so far? So these are one of those things, just take your time as you go through it to not make plus you a mistake. Alright, and like I said, this will require you to sometimes use that knowledge from 9.1, so please make sure you're referencing those questions while you go through the homework. Alright, so number 2 is already factored for you, but are we ready to start canceling stuff out right now?
No.
We first have to find.
Restrictions.
So you can set these equal to 0 and solve, but you can also do it in your head, right? What can't x and be? What two things?
1.
-1 and -3.
-1 and -3, because those would both give me 0 in my denominator. Now that I've found my restrictions, and like I said, if you don't feel comfortable doing that, you can do it like we did on the first slide, do all the steps out. What can I cancel out now?
X plus 1.
Which leaves me with 2 over
X plus 3.
x plus 3. Good. Okay. Now we're moving on to letter B. What do you notice about the denominator?
We have to
It's x
square it.
It's the difference of,
Square.
squares.
yeah, so it's going to be
X plus 4 and x minus 4.
good. What are my restrictions?
4 -4.
4 and -4. So if you want to write it as two separate statements, or you can write it as plus or minus. Does anyone have any questions about that? Okay. What's going to cancel out here in the top and bottom?
X plus 4.
So what is my final answer?
1 over x minus 4.
Mm-hmm. All right. Now we're going to factor this. Factors of 3 that add up to -2.
X plus 1, x minus 3.
Good. X minus 3 and x plus 1. And then factors of -6 that add up to -1.
X plus 2, x minus 3.
Yep, good. I was just double checking. Looks like Dunkin' Donuts colors. So what are my restrictions here?
3 and -2.
Good.
Bro, so dry. Way too dry. Speak from text.
So we got 3 and -2. So does anyone have any questions about how we got the restrictions? What is going to cancel in this one?
X minus 3.
Good, which leaves us with this. Now, can I cancel those x's out?
Yes. No.
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 You can only cancel when it's a product. Do you see the difference between when you can and can't cancel? When there's multiplication between the items. So if you can all do me a favor, and on your homework, look at number 4. I want to just address something about number 4. I'm going to kind of go through it with you. So on your homework, number 4 looks like this. So what do you notice about the numerator? How is it going to factor? It's the difference of?
Circuit squared.
So it's going to be 1 plus 3x and 1
minus 3x.
Good. What about the denominator? I can take out a 4, which leaves me with this, right? Okay. Can anything right off the bat cancel out of this? No, because this is backwards, right? But let's think about this for a second. So I'm going to explain the reasoning of why this works. So if I take this particular factor, okay, I'm looking at this factor in particular. Can't I rewrite this as negative 3 plus 1?
Yeah.
And then couldn't I then factor out a negative 1 out of it?
That makes sense.
And when I do that, doesn't that just become negative 1 times what we have in the denominator? So I don't expect you to go through this procedure every time. If you want to cancel subtractions that are opposite, all you have to do is make one of the terms negative. Doesn't matter top or bottom, you got to make something negative to counteract that flip. Okay? So you can do the whole procedure. I just wanted to explain to you why we're able to do that, and that's the reason why. Flip it and then factor out a negative 1. But if you need to do it, you're just going to factor out and make one of those negative. Now, before you go ahead and cancel anything out, don't forget to find restrictions, of course, but this is how you would approach the problem. All right? So you have the rest of the period to work on your assignment, and that's it for the lesson today.